Al Mueller, a graduate student, a person who has recognized the value of rigorous academic discipline, of singleness of purpose. He's reaching for the stars in more ways than one. His hours are long and lonely. Not many diversions, so minor interruptions are seized upon to break his routine. Most of today's researchers have traveled this route.
Ceramic engineering research.
Well, Virginia, is Al Miller there?
Well, he has a run going now. I'll see if he can come to the phone.
Miller speaking.
Hello, Al. This is Jack. Say, I was over at Sybil's and I left my raincoat over there. I'm stuck. Could you come out and get me?
Well, I'm in the middle of a run. Can't leave it for about half an hour or so. Out of here? Where are you?
I'm in a phone booth down by the overpass. It's pouring down rain out here and I've got my best coat on. I'll use my last dime to raise you.
Well, hold tight. What's the number there?
5431728. Why?
I'll keep you posted. Stay loose. I'll get there as soon as I can. Don't get lonesome.
Al?
You'd think a guy would help a buddy out, but Jack, well, Jack understands which comes first, research or rescue. Still, 40 minutes is a long time.
About time, Al.
Only 40 minutes, hardly an eternity.
Oh, it is when you got an x-ray test to study for.
I got to study too, but I got a pot of coffee on at home. Donnie's in bed. Come on, let's go.
It does make an interesting parallel, though. Imagine being stuck in a capsule in space for 6 months. What do you build such a contraption out of that will hold up and keep the guy alive inside?
Our first manned space flights lasted for a matter of minutes. Then it was hours, then days. But what will happen during extended flights lasting for months or even years? Will our spacecraft materials be able to withstand the whole journey, including re-entry? How important are the long-term effects of hard vacuums, temperature extremes, and radiation? We need to know, need research, now. One graduate student on the campus of a modern university. Al's picked his field, ceramic engineering. 2 to 4 years of his life are caught up in a heavy schedule of classes, independent study, and research. That last aspect is important because the chance to do original research makes the basic difference between most undergraduate and graduate work. Al is a research apprentice, an apprentice at one of the major places where fundamental research is carried out, a university. This is Al's office workshop, space and equipment shared with other grad students like Jack. Sometimes it's not easy to tell in what field research is being done just by looking around. Physics, mathematics, chemistry, engineering, but usually you can tell by the kind of ashtrays or the conversation.
Ceramic products all your life. Remember when you used to drink milk a long time ago? Well, you used glasses and bottles. And when your mother finally trusted you in the bathroom alone, you're surrounded by ceramic products. Tile and porcelain and
How do you
porcelain
tell a
again.
person what ceramics are? Like Jack says, they're such a common part of our lives that many times we don't really notice their presence. But the point is, if you want a material that resists heat, like fire brick, or a nose cap, one that resists corrosion, like glass, one that's hard, like a grinding wheel, or one that combines several properties, high resistance to electricity and high strength under compressive load. Well, if you're after any of these properties, try a ceramic material. And the ceramic engineer is the person who investigates these materials for specific applications.
And reactor parts. And even that precious computer of yours, it probably has ceramic memory units in it. So what makes you think we're on the outside looking in?
Better than being on the inside looking out, especially if it's a telephone booth.
Well, what's this all about?
Oh, just a little adventure in science from last night. Speaking of adventures in science...
Research apprentices, studying on the graduate level and in the process doing research in their field. Important original research, since with all the stringent requirements for materials in this age of space and nuclear developments, ceramic materials must be investigated more carefully than ever before. Al and his fellow grad students are making contributions to the advancement of knowledge about existing and new ceramic materials. Al's research problem is the investigation of the stability of certain compounds of zirconium, oxygen, and carbon in the presence of various gases and at various temperatures and pressures, particularly those which may be encountered in space. His job now is laying out a plan of attack, designing a series of related experiments to be translated into reliable results. To determine which experiments to conduct, Al constructs a diagram of all possible chemical relationships. This serves as the framework for his entire research project. Of course, when questions arise, when he wants to bat around some ideas, Al checks with his faculty advisor, Dr. James Mueller. Dr. Mueller is one important reason for Al's taking his work at the University of Washington. Dr. Mueller, his research work, and his graduates all command a good deal of respect in the ceramic engineering field. Dr. Mueller's job as a teacher advisor is to guide and evaluate Al's progress, but not to do the job for him. Next step, what is already known? What has been done that relates to this problem? Now is the time to check the scientific and engineering literature in the field. Pick a language, any language. The fraternity of the researcher is international. If the results are to be precise, the starting materials must be as free of impurities as possible. And have a pedigree to prove it. The apparatus, designed and built to permit precise measurements under all required conditions. Pressure range, normal atmospheric pressure to 1/5,000,000th of a pound per square inch. Temperature range, room temperature to over 3,000 degrees Fahrenheit. Accurate determination of sample weight at any time, or detection of extremely minute changes in sample weight over a period of time. Inert or reactive gas flow at any desired pressure or temperature. Specially built to do a specific job. As a graduate student, though, Al is still learning, And one of the things he learns is to interpret and evaluate the work of others in his field at regular seminars. Last week, a visiting professor. Today, Jack. And in a session to come, Al will get his chance to explain and defend his work. Part of research is constant evaluation. Evaluation of others' work, evaluation of one's own work, and frequent checks with Dr. Mueller to make sure no relevant factor is overlooked. When the procedures are agreed upon, Al is ready to begin individual experiments. Planning must be done with care, since many separate but related runs will be necessary. Using different chemical compositions, at different temperatures, at different pressures, and for different lengths of time. Many experiments must be repeated under identical conditions, just to make sure that the data are reproducible.
Hey, how much weight is that thing losing?
Oh, about a milligram every 5 hours, or so, Jack.
That's not too much, is it?
It may not seem like much, Jack, but suppose you had a piece of equipment that had to operate reliably out in space for 6 or 8 months. Something the size of your telephone booth, for instance, at these conditions would probably lose 30 pounds a month.
Some days it's hard to get any data at all. Al not only has to know how to operate this equipment to obtain reliable results, but also how to maintain it. Frustrations are part of research. And it seems that research intrudes on just about every activity. While the work for his Ph.D. is in progress, Al has a hard time separating business and pleasure. But the day Al presents the theory and basic rationale of his research at seminar is all business. His audience is attentive and critical. Al's analysis of the problem, the sources of his ideas, the manner in which he plans to carry them through, must all stand or fall on their own merits. His discussion of chemical principles must satisfy the physical chemist. His grasp of metallurgy must meet with the approval of the metallurgist. His applications of thermodynamics must satisfy the thermodynamist. Al's research is part of a multidisciplinary effort. That is, knowledge and techniques from a number of fields of science and engineering are brought to bear on problems involving ceramic materials. This is a major step in his research, to describe it and defend it. Then, back to making runs. But the runs are only a part of the research. Al must also find out what has been happening to the compounds in the furnace, why they are gaining or losing weight, how their structure or composition may be changing. Gas chromatography of samples taken from the apparatus shows what gases may have been taken up or given off by the specimen. The electron microprobe analyzes for tiny impurities or detects minute changes in composition. Observations through a microscope show changes in the physical structure of the samples. X-ray diffraction patterns, by changes in the intensity or location of the peaks, provide information on crystalline composition. Feeding this information into a computer provides a rapid means of correlating and summarizing thousands of readings. But even with these sophisticated means of obtaining data, the next step is Al's alone, sorting from the piles of information the meaning of it all, relating these results to the overall structure of the research project. It's lonely work, Al and a problem. Here in Seattle, only 50 feet above sea level, a material is being evaluated for possible use in space. A search for substance, a search for a new material, a substance that can withstand the rigors of space, and also a search for substance and meaning in research procedures, in research achievement, in functional research results. But Al's work is only one of many research projects going on in the same department, and somebody has to know the overall plan. This means that Dr. Mueller is not only Al's major professor and the supervisor of his research, but the coordinator of the entire ceramic research program. In that capacity, he provides information on research opportunities to students, including student reporters.
This is a multidisciplinary research grant upon the nature and properties of ceramic materials. Some of these problems may have industrial applications tomorrow, next year sometime, but all of them will be more or less space-oriented. Most of our conventional ceramic materials are quite satisfactory in the normal Earth environment, but would not be too stable in the environmental aspects of deep space.
Then this program and from this grant is mainly focused upon graduate students.
That's one of the more important aspects of it, the training of the graduate students. After all, it's the graduate student that is the real research potential for the program. The university is more or less considered the home of basic or fundamental research, and the utilization of graduate students working towards their Master of Science degree or their doctorate are the ones who actually accomplish this research under the faculty supervision. Now, NASA does have other...
This is the bonus of university research. Not just the accomplishment of significant research, but the generation of research potential. The education of young, flexible minds to tackle problems, any problems.
You're the one that wanted to stay and see how it came out.
Okay, I'll call Crane and get us out of here.
I suppose it'll be another 40 minutes in this capsule.
That's better than 6 months. Just stay calm, Jack. Hello? Donnie? What are you doing out of bed so late? Well, go get Mommy. Donnie, don't hang up the phone. Don? You got a dime, Jack? Great.